6-meter ladder is leaning against a wall. If its bottom is pulled away from the wall at the constant 1/2 meters per second, how fast is the ladder top sliding when it reaches 5 meters up the wall? So, the first step to solving related rates problems is draw the problem. So we have a wall, we have the ground, and we have a ladder leaning against the wall. The ladder is 6 meters, and we'll label the horizontal of the ground X and the wall Y. Now the second step is to find the rate we know. We know that the bottom is being pulled away from the wall at a constant rate of 1/2 meters per second. So, step 2, we know that the rate of change for the horizontal part of this problem equals 1/2 meters per second. Now, step 3 is to find what we need to know. So, the problem asks, how fast is the ladder's top sliding when it reaches 5 meters up the wall? So, we want to know the rate of change, d of y over d of t, of the ladder to the wall when y equals 5 meters. Alright, so now we have to make an expression that includes all of this stuff. So, since the ground and the wall will probably make a right angle, we can just use x squared plus y squared equals 6 squared, because it's the hypotenuse. Alright, so now we use implicit differentiation. When we do that, we have 2x d of x over d of t plus 2y d of y over d of t equals 0. Step 6. Well, since the problem says that we want to find out the rate when y equals 5, we're going to plug in 5 into this problem so we can find x and solve this expression that we made. So we have x squared plus 5 squared equals 6 squared. Then we have x squared plus 25 equals 36. X squared equals plus or minus the square root of 11, but since we're talking about meters, it would be positive, square root of 11. And now we are going to plug all this stuff into this expression. So 2 times the square root of 11 times our rate of change, which we know from up here is 1/2, plus 2 times y, which we said was 5 because we want to know the rate of change for that at 5 meters, equals 0. So when we solve for that, we get d of y over d of t equals negative 0.332 meters per second. And the reason this rate of change is negative is because as the ladder is pulled out, the height of the wall will decrease. So that's why the rate of change is negative. And this is your answer.